Hi, Algebra 1 students. These notes are on the discriminant. And this corresponds to lesson 15 in module 4 of your Eureka workbooks. So we just talked about the quadratic formula, which is this x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's our quadratic formula. I need to use a different pen. Quadratic formula. Okay. And then the discriminant is the part of the quadratic formula inside of the radical, inside of the square root. So b squared minus 4ac, this is the discriminant. And the big idea here is that the discriminant tells us how many solutions there are to a quadratic equation. Okay, and the way it does that is depending on if the discriminant is positive, negative, or 0, we're going to have a different number of solutions. So the first one is the case where we have two solutions. Oh, I forgot that marker doesn't work. Two solutions. And this occurs where the discriminant b squared minus 4ac is positive. So I'm going to call that greater than 0. So we say that's positive. And the idea is that if the discriminant is greater than 0, there's going to be a way to evaluate the square root. It's going to be some number, some irrational or rational number, and then we'll add or subtract it from the negative b, and we'll get two solutions. And then the other part of this is, what does that look like graphically? So graphically, our solutions are our x-intercepts on the graph. So if we have two solutions, then our graph must cross the x-axis twice. So we can see like the two solutions are right there and right there. So the next situation would be one solution. And this happens when b squared minus 4ac is equal to 0. Okay, so the idea is if b squared minus 4ac is equal to 0, if you go back to the quadratic formula, well, everything inside this root is 0, so there's nothing to add and subtract. You're only going to have one number, which is negative b over 2a. And what that looks like on the graph is that we'll see the quadratic just touch the graph at exactly 1 point. Notice when you have one solution, the x-intercept is your vertex. Okay, and then the last situation would be no solutions. And that happens when b squared minus 4ac is negative or less than 0. Because if b squared minus 4ac is negative, we're trying to take, then when we plug into the quadratic formula up here, this value would be negative, and we try to square root a negative, it's not possible, right? Because nothing squared, nothing multiplied by itself will equal a negative number. So graphically what this looks like is we don't have any x-intercepts, so we have to draw a quadratic that doesn't touch the x-axis at all. So it could be like opening up above the x-axis, or it could also have like opened down below the x-axis, right? But either way, we have the value is negative, we have no solutions. Okay, so let's just look at a couple of quick examples. So my first example is p squared plus 7p plus 33 is equal to 8 minus 3p. So in order to use the discriminant, I first need to get this into standard form. So I'm going to add the 3p over to the other side and also subtract 8. So now I'm going to be able to get it equal to 0. 33 minus 8, 25. 7 minus 3, 4p. And I bring down my p squared. So now I can see that I can identify a equals 1, b equals, oh, I'm sorry, I subtracted these instead of adding. I should have gotten 7p plus 3p is 10p. So then this b value then is 10 and c is 25. So then if I'm using the discriminant, I'm plugging into b squared minus 4ac. So I'm doing 10 squared minus 4 times 1 times 25. And I get 100 minus 100. Because 4 times 1 times 25 is also 100, which is 0. So now I can see that b squared minus 4ac is 0. So my conclusion should be that there's one solution. So in our next example, we have 7x squared plus 2x plus 5 is equal to 0. So I already have standard form. I already see I have equal to 0. I don't have to do anything. I just have to identify a equals 7, b equals 2, and c equals 5. And now I'm plugging into b squared minus 4ac, and I get 2 squared minus 4 times 7 times 5. Now, I can already tell that this is going to be something negative because 2 squared is 4, and then 4 times 7 times 5 is going to definitely be bigger than 4, right? It's going to be 28 times 5, which is 140. So then I get negative 136. So the idea is that is less than 0, right? So b squared minus 4ac is less than 0. What is my conclusion? That there must be no solutions. Okay, let's do one more example. We have 2y squared plus 10y is equal to y squared plus 4y minus 3. So the first thing I need to do is get this equal to 0. It doesn't really matter what terms I move. I'm going to move this negative 2y squared over and subtract 10y as well. So then I get 0 is equal to negative y squared minus 6y minus 3. Okay, so from there I'm going to identify my a, my b, and my c. And now I'm plugging into b squared minus 4ac. So I have negative 6 squared minus 4 times negative 1 times negative 3. Okay, so negative 6 squared is 36. 4 times 1 times 3 is 12. And then I have a negative, negative, negative. So that's still going to be negative. 36 minus 12 is 24. So I see that b squared minus 4ac is positive. It's greater than 0. So then my conclusion would be that there's two solutions. Alright guys, that's the end of these notes. So please work on the problem set that relates, which is problem set 15.